Okay, hello everyone. I'm Fatemeh, I'm from Stockholm University, and I'm going to just wrap up about the soil health indicators that we are trying to do. First, because we are in AI conference, I asked ChatGPT to create an image based on this definition of the soil, that the soils are formed by mineral debris, organic residues, water, and living organisms. And of course, we know that in reality, the soil is not like that, especially the water is not like that. But I also asked how soil forming, or like the soil formation. That's why it shows me this beautiful soil profile section in the natural setting. But we know in reality that the soil health is not like that. But as Tom also mentioned that we already trying so many of wet chemistry methods like carbon, pH, texture, and so many of physical, chemical properties, but we are lacking of biological and, for example, hydrological properties as well. That's why we need to cover also those aspects if we want to achieve EU missions. That's why I'm just going to give a list of novel soil health indicators that we are trying in some of our pilot sites and in our field works. And of course, we could try also the sound, but yeah, maybe in the next field work, we can try also that one also. The first one is spectroscopy, that you already know about it because Jose, he talked about spectroscopy as well. But what is the soil spectroscopy? We can just simply define as a study of a spectral signature of the soil. But the soils are like forming from different composition, from organic matter, like from clay, different composition. That's why those different composition, they have different soil absorption as well. But the range that we are interested in is visible near infrared range, which is covering between 400 and 2,500. But then here also you can see the original spectra from Lucas dataset, which is a wonderful dataset, about 45,000 spectral data with, along with the wet chemistry data, that there are many researches can be done. But because, as I said, like the soil spectroscopy is a fast and easy method, but also it's a non-destructive method. I mean, you can do it without disturbing the soil. And that's why we tried soil spectroscopy in field and also in in a dried sample also. But because the soil-informed spectroscopy are cheap, there are many soil spectral library that they are developing. For example, one of them is Open Soil Spectral Library, that you can have the information from any location of the world if they are exist. For both ranges, like visible near infrared range and also for mid-infrared ranges, this data is freely available, and if you are interested, you can download. But how we are going to find the soil estimation from the soil spectroscopy? If we imagine that there is a linear relationship between the soil properties and the soil spectroscopy, if we can fit a regression model, then we can estimate the soil properties. But in reality, we know that it's not happening, right? We know that the relation between the soil spectroscopy and the soil properties is more complicated or more complex. That's why we need to apply different machine learning to find this relation and see how it works also. I'm not really going to details of the machine learning, but that's good to know. The other method that we are interested in, ion selective electrodes. There are different electrodes that they are measuring only for like a particular ion. For example, one of those can be pH probes, pH probes that they are easy to use. You can done all of this method in the laboratory setting or in the field. To do that, you only need to have a solution, reference solution, and the ion, the membranes. But the other method that we are testing is eDNA. What is eDNA? Any kind of genetic material coming from environment, whether it's soil, whether it's water, whether it's air, it's eDNA. And eDNA is good for estimating biodiversity. And it can give us the information about different taxa, how many bacteria, fungi, like nematodes they are, but also about the dominating biological function, like processing nitrogen cycle that is happening. The method that we are doing for the eDNA is metabarcoding, and but this method compared to other methods is a bit more complex, and you need to make the samples and then send it to the, we are in AI for soil health, we are sending it to a lab in Spain. But to do that, you just need to have a fresh soil, about like really a small amount, maybe 0.25 gram of soil, and then you add the DNA, RNA shield, and you just shake it for a bit, and then you just send the sample to the library. This is a bit more complex, but still is a valid method. And of course, Bob, the soil enzymatic activity, that luckily, yes, luckily Yasmin explained about that, and I found it also really interesting, and we are also trying in our pilot site. But to do that, you just only need to have a Bob and fresh sample and reaction gel on the plates. The other method that we are interested in and we are trying is microbiometer. This method also is good to find the bacterial, fungi to bacterial ratio. And the method also is easy, is a portable, you just need to have the portable kit. You go to the field, you can do it like really easy, and the farmers can go to field frequently and test their healthiness of the soil. And they can also see if they are doing some management practices, is it working or not? Because if the fungi-bacterial ratio increase, it means that the more nutrients available are in the soil, and But this is a method because it only takes 20 minutes, and you just need to have a small amount of fresh samples, and you make the solution with their powder solution, and you just let it be for 20 minutes, and you take 3 drops of the solution, and you put it in there like a small sheet on the, like in the corner of this. The other method that we are interested to try is infiltration rate, to test the hydrological properties of the soil. There are different methods that they are doing, and those methods, they need tons of liters of water, but this method that we are trying, it's a simple method, and you just need to have a simple tin food, even it can be from the food. And then you just put it in the soil, and you add the water, measure the time, and then you just look at the soil until the whole water absorbs into the soil, and then you just, because they believe that if the soil is healthy, then it should swallow more water as well. So that's why you just need to have a record of intervals. You do that until you get a constant value, and it can give you really good results for soil compaction, soil, The other method that we are interested in is soil aggregate stability. This method also is a smartphone app that you just need to have 3 dried aggregates, and you put it in the Petri dish, take a first image with their app, and then you just add the Petri dish with water and let it be for like 10 minutes, and the app would take a photo after 10 minutes again, and based on the increasing area around the aggregates, it gives you a coefficient of your soil aggregate stability. Here also is the last picture. The first image that we take also the final image, and it gives you like the more the value is, your soil is more stable. But of course, we are trying all those methods, and we cannot still ignore the classical method. We have to go to the field. We have to measure the bulk density, for example. We should still do the wet chemistry data because we need that. And with that, I would like to thank you. And I should say that we are trying those methods.